Let's now take a look at question 10. Okay, for part A, they give us these two statements here and they want us to use this to show that 8 sine to the power of 4 theta is equal to cos 4 theta minus 4 cos 2 theta plus 3. That is for 10A. Moving on to part B, okay, we can see this drawing here. We have figure 1 and figure 2. Figure 1 is the central vertical cross section of an ornament, whereas figure 2 shows the curve with this equation. Okay, they also give us the range value of y. The region R shown shaded in figure 2 is bounded by the curve, the line with the equation y equals to 8 pi over 5 and the y-axis. The ornament is modeled by the solid of revolution formed when R is rotated 360 degrees about the y-axis. The units are in centimeters. So what happened? We are rotating it here 360 degree. Using algebraic integration and the result in part A determined in cm cube the volume of the wood needed to make the ornament. So we want to find the volume by using integration and result in part A. We want the answer, okay, up to 2 significant figures only. Now moving on to part C, they want us to comment on the suitability of the model given the density and the mass of the ornament. Let's now begin with part A. What we want to do is we want to find sine power of 4 here. So because of sine, that means we have to use this one. So what we're going to do is we will take z minus 1 over z to the power of 4. Okay. So we'll do two types of computation. On our right hand side, we will use binomial expansion. Whereas for our left hand side, we will use our definition. So this will use definition. Okay. So let's expand this. So it would be 4c0 z to the power of 4 negative 1 over z to the power of 0 plus 4c1 z to the power of 3 negative 1 over z to the power of 1 plus 4c2 z square negative 1 over z square. Okay, plus 4c3 okay, z to the power of 1 negative 1 over z cubed plus 4c4 z to the power of 0 and negative 1 over z to the power of 4. So that is our right hand side. Next line, we will use the definition. So what's the definition? Okay, for power of 4, so it would be 2i sine theta to the power of 4. So that is from our definition here. Okay, so let's do this. 4c0, that would be 1. So z to the power of 4. Here would be minus 4c1, that would be 4. We'll get z cubed over z plus 4c2. Okay, so that would be 6. Z square over z square. I do not need to compute the rest because it will be like 4 and then it will be 1 as the coefficient. So this one will be z over z cubed plus 1. Okay, and then it will be 1 over z to the power of 4. Now let's expand our left hand side. So we have 2 to the power of 4, I to the power of 4, and sine theta to the power of 4. And what happened for our right hand side? We will simplify. So this one will be z4 minus 4z squared plus 6 minus 4 1 over z squared plus 1 over z to the power of 4. Now let's write down, okay, let's solve our left hand side. 2 to the power of 4 is 2 to the power of 4 is 16. Okay, we know that I square is negative 1. Negative 1 square is 1. So here would be sine to the power of 4 theta equals to. Now, for our right hand side, I will start using different colors. Okay, so here it would be z to the power of 4. Okay, I'm going to combine it with plus 1 over z to the power of 4. Next, okay, I will have minus 4z square minus 4 1 over z square. And then I can use like the previous color back, plus 6. Okay, so our left hand side would be 16 sine to the power of 4 theta equals to, okay, the red one would be z to the power of 4 plus 1 over z to the power of 4. Okay, now I will take out the common term, so I will take out negative 4 and we will get z square plus 1 over z square. Next, it will be plus 6. We are done with our left hand side. We're not going to simplify that anymore. That's it. Okay. Now what we're going to do is we're going to use our definition here. So we know that, okay, when it is z to the power of n, okay, that would be equal to 2 cos n theta. In this case, your n is 4. So we will get 2 cos 4 theta minus 4. And then bracket. Here is also plus, so it will become 2 cos 2 theta plus 6. Okay, let's expand and simplify. We will get 2 cos 4 theta minus 8 cos 2 theta plus 6. This is actually equal to 16 sine to the power of 4 theta. Okay, let's check our question. Okay, our question, they want us to prove that it is 8, not 16. So what we have to do now, divide all of this by 2. So let's divide this by 2. So we will get 8 sine to the power of 4 theta is equal to cos 4 theta minus 4 cos 2 theta plus 3. That's it. We are done with part A. Moving on to part B. Now we want to find the integration or the volume for this one. Okay, what's the formula for volume? So B, we want to find volume. The formula for volume would be, okay, pi y1, the limit of y, okay, until y2 x squared dy. So what we need is x squared. So let's find that one first. So what we have here is x. X is equal to sine squared, okay, half y. Now what we want to do is we want to find square. So we're going to square this and we're going to square this. So we will get x squared is equal to sine to the power of 4 1 over 2y. Now they want us to use the result that we get here. But notice that the result here we have got 8. So what we have to do is, let's simplify this, okay. I will put 8 here. Okay, so inside here I should have 8 sine 4 1 over 2y. But over here we want our coefficient to be 1. Therefore, we have to multiply by 1 over 8. Okay. So we'll get 1 over 8 here. And then let's substitute what we have in part A. So here would be cos 4 theta. But in this case, it's not theta. In this case, it's half y minus 4 cos 2 theta, so 2 half y, plus 3, close bracket. There we go. Let's expand and simplify this one. So we will get 1 over 8, okay, cos 2y minus 4 over 8, that would be half, cos y plus 3 over 8. That is the equation for x squared. So volume is equals to pi y1 to y2. Okay, so what is our y1? y1 is 0 until 8 pi over 5. And over here it would be 1 over 8 cos 2y minus 1 over 2 cos y plus 3 over 8 dy. Okay, so we can straight away integrate this. Here we will carry forward 1 over 8 cos 2y. If we integrate, we will get sine 2y. Now we have to differentiate 2y, we will get 2. Minus 1 over 2 cos 2y, integrate, we will get sine y. Plus 3 over 8y. Okay, what are our limits? 0 and 8 pi over 5. Let's now substitute the value. Okay, so we have 1 over 16 sine. Okay, that would be 16 pi over 5 minus 1 over 2 sine 8 pi over 5 plus 3 over 8 multiplied by 8 pi over 5. Now we will substitute 0. Okay, notice that sine 0 is 0. So when we substitute, this one would be 0. This one would be 0. And this one will also be 0. So that's it. So I just have to write minus 0. Let's compute the value. Let's just use our calculator. 1 over 16. Okay, sine 16 pi over 5. Okay, make sure our calculator is in radian mode, yeah. Minus 1 over 2 sine 8 pi over 5. Oh, I can. Okay, over 5 plus 3 over 8, close bracket, open bracket, 8 pi over 5. Why we can just simply use our calculator? Because they want us to give the answer up to 2 significant figures. Don't need like exact value for this question. So here is 23237 pi. Now let's multiply by pi. Okay, multiply by pi, and we will get 7.3. This is volume cm cubed. This is up to 2 significant figures. Okay, we are done with part B. Moving on to C now. Okay, they give us the density and the mass of the ornament, and they want us to comment on the suitability. So let's compute the volume of the actual ornament. So volume is equal to mass over density. Okay, so what is our mass? Our mass is 6 over 0.85. So let's compute that. 6 over 0.85. So we will get 7.06. Okay, cm cubed. 7.06 cm cubed and 7.3 cm cubed are closed. Okay, therefore it is a suitable model. Okay, that's it. We are done with this question.